Okay, so to all of the new faces, welcome. My name is on the board. Full name is Joshua Heckroodt, but everyone calls me Josh, and I encourage you all to do the same. To everyone who was here 2 weeks ago, welcome back. Because we're trying to do this as kind of a little bit of like a continuous kind of group of sessions. Probably what we'll do today is we are just going to pick up where we left off like 2 weeks ago. If you're new, it might seem a little bit confusing, and I'm kind of sorry about that. But the kind of best advice that I can give to you if you kind of are joining the session for the first time is, if you want to, you can come up to me afterwards, and I can give you kind of like some sort of a template document that you can use to get started. Otherwise, yeah, kind of LaTeX is a little bit of a repetitive thing in the sense that most of what it is that we're going to do here today is just going to be kind of different versions of the same kind of command, and so you'll kind of if you just pay attention throughout the course of what it is that we do, you'll sort of pick it up as we go along. So 2 weeks ago we started producing a document that looks like this, and the aim basically with this document is, because there's a whole kind of array of kind of complicated expressions in here, the aim is to work through this document from start to finish, and kind of cover how we can produce all of these sort of intricate expressions along the way. Much of this looks quite intimidating. I mean, we've got integrals with square roots and kind of matrices and determinants and blah blah blah. Don't worry, well, if I do what it is that I'm going to do correctly, then all of it's going to make more sense towards at the end. So where we got to, this document's going to disappear. Sorry about that. So where we got to last time, and this is just kind of to make sure that people can kind of follow along, even if you are new. The website that we're using is called Overleaf. So you're going to go to your search bar and just type in Overleaf. Because I'm already kind of signed in, my screen looks like this. If you're not signed in, then it might not look like this. You might immediately be greeted with kind of an open document. Otherwise, just click this new project button, name it, and that'll kind of it'll open your new project for you. So where we got up to, as far as kind of reproducing that document that we were working on 2 weeks ago is concerned, is here. So if I open this project up, sorry, I need to make this bigger. Can everyone see, or do I need to make this a little bit bigger? Is that fine? Okay, cool. All right. So where we got up to last time is here. Yeah, so I'm trying to think about what's going to be the best way to approach this, given the fact that there are some new people in the room. Okay. Okay. So if you're new, if you weren't here 2 weeks ago, and a lot of this looks fine, which it probably will, the most important things that you kind of need in order to follow along with the stuff that we're going to be doing today, is everything from lines 1 to 16, and then this final line down here, 32, which just says end document. And so that's kind of, those are the most important bits of code that we have so far that you're going to need. Yeah, the most important thing is just that you have this begin document and end document down there. All of the stuff above begin document just controls the layout of your document, dictates how it looks. Also, we had an issue with this last time. If you're going to try and kind of copy a lot of the stuff down, this character here is not an L. That's a 1. So that basically just says margin equals 1 in. So you're going to have a margin that has the width of 1 inch. So yeah, so just to reiterate that, if you're new, as in if you weren't here 2 weeks ago, you're going to want to copy this. And then in addition to that kind of line down there at the bottom that says / end document. So. While I'm here, let me just sort out some of the formatting. Oops, sorry. Here you go. So this is where we got up to as far as recreating that document is produced. And I'm going to try and kind of not speed through the rest of what it is that we're going to do too quickly, because I'm trying to be mindful of the fact that, yeah, some people are probably going to want to copy that down just so that they can follow along properly. Okay, yeah. And then I think what I'm going to do is kind of just go ahead with the rest of that document that I had up just a moment ago. I'm not going to keep swapping back and forth between this and the document itself because you know, some people are still going to be copying. But fortunately, I have the document open in front of me, so yeah, just follow me, basically. Right, so what we did last time was we kind of looked at the section command, which basically just is, you kind of see it reflected there in the big bold print that says problem statements up top there. Sections number themselves automatically. That's the beauty of the section command. Underneath it, we started our paragraph text, which just says, today we're going to be proving the following statement in LaTeX. We looked at the framed environment, which puts things in a nice box. And we looked at center, which moves the text off of the left margin and into the middle of the screen. We looked at this equation environment, which is going to be very, very important to us. Specifically, the equation environment also adds labels to your equation, which is why the equation that you see in the box there has a little 1 next to it. Started looking at fractions and some basic math symbols, of which pi is obviously the first and foremost example. So from here, we can actually start our next section, which is going to be just a section called solution. In Overleaf, you can hit recompile, and that will assemble your document for you. Otherwise, you can turn auto compile on, which I'm going to do. Oh, whoops, good point. Need to move that out of center, so that goes down here. Oh, sorry. Forgot how to do everything today. Okay, so there we go. And actually, you know what I need to do as well? I need to put that outside of paragraph. Okay, there we go. Right, so that's our next section. As per usual, we tag in our paragraph tags here. So in between here is where all of our text is going to go. So the first thing that I'm going to do is actually define the where am I going to do? So I'm going to define a domain of integration here. And basically the way that we're going to do this is we are going to say let, and then you might remember from last time. So we have these two dollar signs, and the dollar signs are inline math equations. Sorry, can I am I okay to scroll up? Is everyone okay with that? Can I go like there? Yeah, that's fine. Sorry, because I'm just being mindful of the fact that currently the text is way down here, so some people might not be able to see. So I'm just going to leave it there for now. And then maybe just make this a little bit bigger. Push it further down. Yeah, I will do. Just a quick show of hands. Who's still copying from the initial lines? Okay, all right. I'm gonna scroll down a bit then. So, okay, yeah, I'm just gonna leave it there. Right. Okay. So yeah, so we have these double dollar signs. These are inline math equations, and what we're gonna do is we're gonna define a set called S1. And it's going to look like this: S superscript 1, and the symbol for superscript is just this up arrow. We saw this last week as well. That's going to show up as S, and then the 1 is just a little bit above it. And what we're going to do is we are going to introduce some set notation here. So in LaTeX, as you can kind of already tell, I mean, kind of curly brackets are really quite important. They are kind of what you use to pass arguments into the specific commands you have. So for example, you know, we have the section command, the end command, and all of them have these little curly brackets afterwards. So in LaTeX, you can't actually kind of denote, you know, curly brackets that start and end set notation using just the normal curly bracket key on your keyboard. You have to use L brace, so \L brace. And at the end of it, you have to have \R brace. So these just stand for left brace and right brace. And this is kind of a common theme in LaTeX where you have, if you have something that has both a left and a right component, something like brackets, whether it's curly brackets, kind of triangular brackets, square brackets, they can all kind of have these L or R. You have a question?
Well, no, it's just you don't really have to write
backslash algorithm, just do backslash curly bracket.
So that is the other thing that you can do as well. Yeah, so what you can do, so what this lad was just mentioning to me is what we can do as well, instead of L brace and R brace, is just do backslash curly brackets instead of just doing curly brackets on their own. That'll work just fine as well. You see there the documents refreshed and you still get those curly brackets there. So yes. So yeah, so I don't know if in general if this method will kind of adjust the size as well. But I yeah, you would need that. Yeah, you would need that as well. But okay. So these are curly brackets. What I'm going to write in this set, or what this set is going to be comprised of, is the pairs of values x and y, and then I can do backslash in, backslash math b r squared, and that basically comes up looking like that. So you can kind of see where the x and y come from there, just the x and y in the brackets there. This in, once again, is the inclusion symbol, so that's the kind of weird looking e. And then that backslash math bb, basically that just means that whatever we put in the curly brackets afterwards, we're printing that in math blackboard bold, right? So that's kind of why the r there looks well like the symbol that denotes the real numbers, right? So we have these elements, and we want these elements specifically to satisfy the relationship x squared plus y squared, and then we need in this case we need a less than or equal to symbol, which you can't do by just kind of writing. I'm gonna scroll down just a little bit here as well, which you can't obtain by just writing this normal kind of less than symbol on your keyboard. If you do that, it will produce a symbol for you. It's just going to be the less than symbol as opposed to the less than or equal to. The less than or equal to symbol we can gain access to using a specific command, and that command is backslash LEQ, presumably, which just means less than or equal to. And for anyone wondering, if you wanted to do greater than or equal to, you swap the L out for a G. So backslash GEQ is going to be greater than or equal to. And you can see that dot sign. Yeah, there you go. That sign flips left versus right? So, but we want this to be less than or equal to, and specifically we want it to be less than or equal to a squared. And so S1 is just a disk, right? It's just the closed disk of radius a in R2, just in flat space, right? So, and this is relevant to us because we're going to be integrating a pretty ugly looking function over it, but it's all in the name of learning how to use different commands. So, and from here we're going to say, and hence so we need another inline math equation, and now we're going to be defining a function. So this is going to be f, and it's going to be defined on S1, and it's going to map into the closed interval from 0 to a. And how we do this, so obviously we need kind of that, arrow notation that everyone's kind of, used to seeing in maths. So what we can do here is we can do \2. And when overleaf compiles that, you'll see that an arrow pops up to the right of S1. So now we're in a position where we can kind of write down what it is that that S1 gets mapped into by F. And this is just going to be the closed interval 0 to a. Notice how for the curly brackets, I've had to do \/ curly brackets, but for the square brackets, they work fine. Right, so I just got my square brackets there, and they show up in the document kind of normally. That's not really nothing too special about that, right? So. And now we can say we want this function to be given by. Okay, and now what we're going to do is we're going to introduce another equation environment, but it's going to be a little bit different from this one here, right? So this equation environment, when you write it like this is a labeled equation environment, right? Which means that whatever goes in between the begin and end equation there is going to show up with a little number next to it, right? If we don't want that to happen, we actually technically have two options, and I'll show you both. The first one is on a new line, you put a double $sign symbol, and then 2 lines below it, you put 2 more $signs, right? And anything that I now put on this line, right? So instead of having kind of your begin and end tags, you just have these double $signs. Anything that I put in between here is going to show up as an unlabeled equation, right? So I can type in f of xy equals, and I'm going to do the square root of a squared minus x squared minus y squared. Why is everything red? No. Okay, there we go. Right. So we get our equation. So this is just the definition of f. And you can see on the page just to the right, I don't know if I can scroll down on this right. So there we go. You can see on this page, okay, so it showed up exactly the same way in which our v is equal to 4 over 3 pi a cubed showed up, except the only difference being that, of course, the bottom one has no label and the top one is labeled 1, right? The second way of doing this, and just to show you that it's identical, I'm just going to copy and paste this quickly. So the second way of doing this would be, again, using the equation environment, right? But the difference this time is that instead of just doing equation in both, you add a little asterisk here. So if you do that, so initially it shows up as 2 because that was when I just had equation. And then when it figures itself out again, that label disappears, right? So, and this is this also is a little bit of a recurring theme in LaTeX. Adding this asterisk to an environment changes the way in which the environment actually shows up on the page. So in this case, it means that instead of having a label, the label disappears. Right? So that's how that works. I'm going to get rid of this top one with the double dollar signs. Just in case anyone's interested, I usually use this one just because it's easier to type $2 signs than begin equation asterisk blah blah blah. So, but I'm going to get rid of this one for now. You can do that as well. Yeah, there's loads of different ways of kind of doing basically the same thing in LaTeX. Those are just 2 methods. Yeah. Okay. So now we can get into some. Interesting and complicated looking expressions, right? So let's do. Okay. So we've defined our set. We've defined a function on the set, and now we want to integrate it, right? If you actually want to follow along with this proof, feel free. I'm not going to explain the working that I'm doing, just like most of our professors. You're just going to have to take my word for it. So from here, what we'll do is we'll just say, okay, so we have these 2 things, then, and now before I write the next integral, I just want to spare a quick moment to talk about the actual kind of conventions that the integral symbol in LaTeX kind of abides by, right? So I'm going to do the usual, these 2 kind of double dollar signs. Normally, when you're working with kind of big operators, things like kind of sums, things like integrals that you don't really want to be squashing onto a single line, I tend to do this. Although sometimes it gets a bit inconvenient if you have kind of, you want to reference one integral multiple times in slightly different forms, and then you don't want to have kind of, a page's worth of just one integral kind of almost copy and pasted multiple times. Then you can put it in one line, but in general, I kind of tend to put it in kind of this environment. So if I wanted to write, for example, just the usual kind of, base case example of an integral, just the integral of some function f of x from a to b with respect to x. The way that I normally do it, and the reason why I say the way that I normally do it is because, again, as is the case with a lot of stuff in LaTeX, there's many different ways of doing the same thing. But the way that I normally do it is you do \int. That on its own is just going to give you an integral symbol when the document catches its breath. There you go, just blank integral symbol. If I wanted to add bounds, right, so a lower bound and an upper bound to this integral, to add a lower bound, I do underscore. And then it's good practice to everything that you want in the lower bound, you put in curly brackets. So for example, we'll do lower underscore curly brackets a, and that's going to tack an a onto the bottom of my integral there. And then to do upper bounds, this may not be all that surprising, but you just do this little kind of the same symbol that you use to write down powers, right? So I'm going to do put b down as an upper bound. And then the function that I'm integrating here is just f of x, that I can just write in normally. And the variable that I'm integrating with respect to is x, right? So we can just put a little dx at the end. Now, Right, there you go. Okay, so that's an integral. The dx is normally where a lot of people start imposing their own kind of preferences. Because I mean, you know, if you pay attention to the d there, you'll notice that it's a little bit slanted. That doesn't have to be the case. I think if I remember the command correctly, you can do math rm, and that will straighten out the d. So, you know, now it's kind of upright as opposed to being a little bit off to the side. Some people prefer to do, you know, they prefer to have a little space in between the dx and their function. And for that, you can use this little tilde symbol, and that will kind of just move one a little bit further away from the other. But these are all just particulars. You know, this is just a matter of preference. I mean, normally the way that I do it is I don't even bother with this math rm nonsense. I kind of just go, all right, a tiny bit of space and then just a normal d. That's kind of how I do it. But this is the basics of how you do integrals, right? This is kind of the basics of how you do integrals. There are more complicated integral symbols built into LaTeX as well. For example, if I wanted to turn this into a double integral, then I just add another I. And if I add another I and the document catches its breath, then you'll see a second integral symbol show up. All right. Of course, as per usual, this is not the only way of doing this. I could also just have done \int and then another \int. But the difference is if you pay attention to that symbol there, that moves them a little bit further apart. Right? Which, I mean, for some odd reason, mathematicians have become obsessed with neatness over the years. And so that doesn't look especially neat in comparison to just using two I's. So normally what they'll do to denote double integrals is they will just do this kind of \ii. I'm actually going to leave this double integral up because the next line in the document that we're trying to produce actually does include a double integral. So I'm going to leave it like that. And specifically the double integral that it includes is an expression for v that includes no upper bound, but it does include a lower bound. And the lower bound is s1. And we're not integrating with respect to x anymore. It's a, you know, it's an integral over an area, so we can do dA. Right, so we get that expression there. I think. Okay, well, there's a factor of 2 out front, which I suppose is probably quite important for the ability to work in. But okay, so we get this. Right, and now what we can do. Oh, okay, that broke something. Oh, it's a server error. Whoops. Yeah, there you go. Right, okay. So from here, the jump from this integral to the next one is quite big. It's going to look very complicated, but I'll try and talk through it in a way that makes sense, hopefully. So what we get basically is we from here actually substitute the expression that relates to set S1 and our function into the integral, and just kind of, it sort of just blows up a bit, right? So what we end up with here is we still have the factor of 2 out front. Now what we're doing is we are integrating once from -a to a. Right, and because this is a double integral, the bounds on the inner integral are actually going to be functions, right? So what functions are they going to be? Well, the bottom one is going to be, and I'm just going to, why is this switched order? Just going to wait for the document to catch up. Okay, there we go. So the bottom function is going to be, so it's minus the square root of a squared minus y squared. So that would be minus square root a squared minus y squared. That looks like that, or not. Right, I'm missing a closed bracket. If I add that in, that's going to show up on the bottom bound. And yeah, it's not an especially nice looking expression, but this is kind of just goes to show the amount of stuff basically that you can include on the lower bound of an integral. In fact, if you wanted to, you can include an integral on the lower bound of an integral. I don't know why you would want to do that ever, but it is possible. And also just kind of while we're on this topic, just an important note about these kind of the brackets that I've kind of wrapped everything in the lower bound in. Let's say, for example, I got rid of these brackets, right? So the curly brackets on the outside, what would happen if I just got rid of them? Then LaTeX would only take the symbol directly adjacent to the lower bound, to this kind of underscore, and actually put it on the lower bound.
right? So you see there that minus is included in the lower bound because it's the first symbol after the underscore, and everything else just goes normal on the line, right? So this is kind of why I was saying if you only have one symbol, right? So like, for example, that's kind of why this, upper A, that's why I didn't wrap that in curly brackets, because it's just one character. So I don't need to worry about, oh, but what if some of the stuff shows up in the bound and some of it shows up on just, as the integrand? Not a problem because there's only one character, right? For this one, right, I need the curly brackets again because there are two characters, minus an A, and then the same goes for the last one as well. Right, so let me put these back where they were. And then the upper bound is just going to be square root of a squared minus y squared. And I need to close that as well, right? The integrand is literally just going to be the expression that we have for f. So this is just going to be the square root of a squared minus x squared minus y squared. Close. And then we're integrating that first with respect to, what did I say? The x, and then with respect to the y. Okay? So there is our integral. Cool. Show of hands, who's done, who of you are first years? As in, who's in first year? Okay, all right, cool. This is term 1, so okay. Have you guys started looking at Jacobians? Okay, yeah. It might be taught in term 2, or it'll be taught in term 1 of methods 2. Either way, yeah, pretty much. That's the idea. Because I mean, we're working with a circular domain, right? I mean, r squared equals x squared plus y squared over there. So you can just flip this entire problem into polar coordinates, and the expression that you end up getting looks a lot nicer. But there's a bunch of cool stuff that we get to do before, we end up just going, oh, this is the answer. And the first of those things is we're going to write down an expression for the Jacobian, right? So I'm just going to say converting this problem to polar coordinates by substituting. Is my spelling remotely correct here? Okay, so x equals r cos of theta, right? So cos, if I just write that in as is, that's going to show up looking very italic. Yeah, so right, it kind of shows up looking like that, but it's also a command, right? So if I do \cos, it looks well, a little bit different, but trust me, if you were like writing a dissertation or something and you just had the italics, cos, your supervisor would yell at you. I am speaking from experience. So yeah, there's that. So we're saying cos of theta, so we can just do \theta. That one's not, there's no real science to that one. And then we can also do, using the substitution, x equals r cos theta and y equals r \sine and \theta again. Right, so we can say we obtain the Jacobian. And then for this, what we're going to do is we are going to introduce some more out-of-line maths, right? So kind of double dollar signs again. And the notation for this was dx, a little space dy. And that, okay, right. So that's equal to, I'm actually going to write on the board for this. That's equal to the determinant of a specific matrix, right? The matrix whose determinant that is denoted using this. Actually, no, it's not that. I lied. It's r theta, not that one. So these are the variables that we're introducing. Right, so the matrix is denoted using this. What we do when we want to denote the determinant of a matrix is, instead of using kind of brackets like this, you just use, well, basically just really big absolute value symbols, right? So, or modulus symbols, whatever you want to call them. So we just use this, right? But the problem is that if we, for example, were to just do, so we can do a straight bar on my keyboard, that's shift and then the / key. On your keyboard, it might be something else, but it should just show up as a straight bar. So if we just do the straight bar, it looks like that.
which is fine, right? But we're going to include a fraction next, yeah? So in particular, we've got this as our command for the fraction. The first argument is the numerator, and the second one is the denominator. And these are the partial derivative symbols, right? So they're not normal Ds, and they have their own special command because you're not going to find them on your keyboard. I promise you, I've looked. And the command for these is \partial. And that is going to show up as a partial derivative symbol. But you'll notice when it does, and actually maybe I should just write out the entire fraction first. So like I said, it's partial xy, and then that's the numerator, and then on the denominator goes partial r \. All right. Oh, whoops. I didn't need these curly brackets here. My bad. Right. Okay. So there's our. Right. Yeah. There you go. There's our entire fraction. Cool. Now I can do at the end. I can just kind of close this off with another one of those straight bars, but. The problem here, and again, it's a purely stylistic problem, as is the case with much of LaTeX. That's kind of why we're learning it, right? Is to make our math look nicer than what we could ever hope to write it down as. So the problem with that fraction over there is the fact that the bars on the side don't line up with the height of the fraction at all, right? So it just looks a bit weird. But it doesn't have to, because, you know, LaTeX exists. So what we can do, and these are very, very, very commonly used commands. You can use them for any kind of bracket, right? So square, curly, normal, triangular brackets, anything that you want. And you can also use them for these bars, right? So we're going to type in here before the one on the left, \left. And I hope this works. Okay, if it recompiles, that'd be pretty cool. Yep, there you go. Right, so notice how that's now stretched that the vertical bar on the left there, kind of, it's made it taller. And then, very unsurprisingly, if we go to the one on the right and type in \right, we end up with the exact same thing happening on the right-hand side. Yep. So that looks like that. So as far as kind of this is really the standard way of. Sorry, let me scroll down a little bit. There you go. So this is really the standard way of doing things when you have kind of left and right delimiters on your expressions. You should be using \left and \right. There are obviously, as per usual, other ways of doing this. In particular, there are commands that, independent of whether or not this is a left or a right delimiter, or whether it kind of is paired up with another left or right delimiter, there are expressions that we can use to kind of manually control the size of our expressions that kind of, you know, go on either side of these things. And so just as kind of a demonstration of that, what I'm going to do is I'm going to write down the commands that control the size, kind of all just in one line so that you can see how they progress. And I really, I really hope I remember the order in which they go, but there's a chance that I don't. If I don't, I'll just sort them out. But the commands basically go, so \big, right, quite literally is a command. And that is going to adjust the size of that bracket. And maybe I should just include a normal bracket here as well. Put some spaces in between there just so you can see the difference between the two. Just so you can basically tell that big actually does make a difference to the size of our bracket. So let me just scroll up a bit here. It's not very significant yet, but it will get there. 3 more spaces. We also have big with 2 G's. This is not a joke. All right, so that one's really big, right? Which means that there's something else that goes in between. Capital B. Yep, that's the one. So you have \big with a lowercase b does one thing, \b with an uppercase b does something else, big with 2 G's does something, and then finally, not very surprising, but this is the biggest one, which is big with 2 G's and a capital B, and it looks like that. Right, so there are things that you can do to kind of manually control the size of your delimiters, right? And this is it. You use big. Sorry? Yeah, so I think that is actually a thing as well. If I'm being completely honest, I've never used it. I think that's long. Okay, well, huge is rather disappointingly small. But there's large work? Oh, also, by the way, this process that you guys are seeing in front of you right now, where it's just kind of, oh, I have a feeling that this command exists and I'm going to try it out and see what happens. Very, very commonplace in LaTeX. LaTeX is a very iterative process. You try something, it doesn't work. You Google it, Google tells you the answer, you go and figure it out yourself, right? So, is there a small one?
There is.
Really? Great question. No, well, okay. Maybe the thing is, I think some of these commands will apply to text as opposed to math, right? So, for example, that's definitely just an optical illusion, but we can check it out. Let's take this and put it way back at the front here. No, wait, hang on. What? Oh yeah. It made all of the other brackets tinier. Okay, well, all right, whatever. Yes, if you want to figure out how the tiny command works, you know, Google is your best friend, and I recommend consulting Google. I don't know how it works. But anyways, so, right, okay, that's enough of toying around with that. Bottom line is, there are commands that you can use to kind of adjust or control the size of your delimiters a little bit more precisely. I actually use these quite a lot, as opposed to left and right, which I've been told is not a good practice. But, you know, if you're like writing lecture notes and stuff, I mean, who's going to see them? Unless you sell them on Chegg, which you're not, for legal reasons, you're not actually allowed to do that. That's not actually a thing that we're allowed to do. But anyways, let's move on. So basically, we have this expression, like I said, this thing in the brackets here, or yeah, kind of in these two delimiters. This is actually a matrix. So there's a countless number of ways in which you can kind of produce a matrix. I have a standard way that I like to use, and I'm gonna show you how to do it here. And I'm not actually going to show any of the other methods, because much like what just happened with the, oh, you can manually adjust the size of your delimiters. If I started talking about the different ways of doing matrices, I mean, it would take up the rest of the session, right? It's just, there's a lot. Okay. So I'm going to show you guys how I do it. Sorry, question? Yeah.
Like between the 940 and 44, there are only the following but it doesn't change.
What do you mean?
So usually we have two, like for 31 and 38.
So there's those.
And oh, so what do we do for 41?
So basically, this starts an equation environment. Okay. Everything that goes here is that integral that you see on the page. This ends it again, right? Okay. So this is just paragraph text, right? These are outside of any math environment. Here we start another math environment, and that's that dx, that fraction that we just worked on, that you see, and here we end that again, right? So if I start typing stuff here now, so where the matrix, blah, 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 that's going to show up underneath that amount here, right? Yes, correct. Yeah. So only the actual kind of equation goes in between these two pairs of double dollar signs, right? So does that make sense?
Yeah.
Okay, cool.
I was thinking like the dollar signs like in the middle.
Yeah. Well, I mean, probably, but I don't know how to do it. I don't know how to do it. I'm not going to lie to you. I normally just leave it in the middle. I don't know. But there almost definitely will be a way of doing it. I'm not sure what the way is. Right, okay. Also, sorry, I did just notice that actually I'm missing two expressions at the end here, and it's dr and d theta. That's yelling at me. I don't really know why. Okay, stop yelling at me. Right, okay. So where the matrix? Okay, so we're going to be writing down an expression for this matrix that I was talking about earlier, this one including the partial symbols. I'm not going to rewrite the fraction that does all of the partials. So I'm just going to copy that instead. Copy that, paste it down here. So that's going to put that same fraction that we have in between the kind of absolute value looking symbols, the determinant symbols. That's going to put it down there. Okay, so How I do matrices is I do them using square brackets. I don't really use round brackets for matrices. You can if you want to, and I'll kind of show you how to do that. We have our left, right? So left square bracket in my case, because I prefer square brackets. If you want to use round brackets, kind of unsurprisingly, but you just replace the square bracket with a round, right? So that's how you would do that's how you do that. I'm not going to do that though. I'm going to stick to square brackets. Once I have this left, actually, probably just so that we can kind of see what happens as we type stuff up, I'm going to put this closing square bracket there as well, but I'm going to put it on a new line. Yeah, I'm going to leave that there. Right, okay. Now, the next thing that we do is we want the left and right brackets to adjust their size according to how big our matrix gets. And the only way in which we can force the left and right brackets to do that is using these curly brackets, right? So after the opening square left bracket, I put a left curly bracket. And then before the closing right square bracket, I put a close curly bracket. Let me scroll up a little bit again. Right, okay, so that's what our expression looks like so far. And now there's another environment that I'm going to introduce, and it's called the array environment. There are simpler ways of doing matrices, but I find that this way gives you the most control over what your matrix actually looks like. So I tend to stick with this way. And so what we do is from here, right after this opening kind of curly bracket that we have here, I'm going to do \begin and put array. Right. I don't know if this is going to update properly because we also need an end array, strictly speaking. And actually, what you can do if you want to add that so long, just so that you can keep track of what happens as you kind of change what happens in your matrix, is right before this closing bracket, you can put in the end array. So that's going to give you something. Right, okay. So the thing that it gives you is a big fat error message, which we're not really going to pay too much attention to right now. We're just going to focus on the code that we're producing because it's going to fix everything, right? That's kind of the point of this whole exercise. I'm just going to change the size of this a little bit so that we get this and by a little bit I mean quite a lot, but anyways, so that we get this kind of array thing in here. Okay, so we're substituting two variables for two different variables, which unsurprisingly means that our matrix is going to be 2 by 2. And we can indicate how many columns we want in our matrix using another set of, using another set of curly brackets after array. And we put in the letter C, followed by a space, followed by another letter C. And these curly brackets after array, right? So just on this slide for a second. So these curly brackets after array, these indicate the number of columns that we have, but also it indicates the style of the columns that you have, right? And once we've kind of properly typed up the whole matrix, I'll talk a little bit more about how it kind of dictates the style. But for the time being, just know that if you added, for example, another space, another C at the end here, that would mean that you have a matrix that has 3 columns, right? So that's how that works. Also, that said, if you wanted to do row vectors, just a single C, just one C will do, right? It's just got 1 column. So. Right, okay, so from here, what we're going to do is on a new line, we are going to start typing up some expressions. And these expressions are going to correspond to this actual Jacobian matrix, right? So I'm going to go through this kind of quickly, and then I'm going to talk about it a little bit at the end, just to give everyone, time to catch up and just to make sure that everybody gets what's going on, right? So what we're going to do here is we have partial, let me make sure that I get this right. So partial x, by the way, you do need this space here. If you don't do that, LaTeX is not going to recognize partial x, however you want to pronounce that, or it shouldn't. Right, okay, I mean, nothing shows up and you get this little error symbol here, right? So you do need that space. So we've got partial x, and we're differentiating this with respect to r. Oh, whoops. I need a backslash there, my bad. Okay, so now we have something in our matrix, which is nice. There we go. Now, to access the next column over, right? So this is kind of this what we've just typed in now is showing up the first column. To access the next column over, what I'm going to do is put space, an and symbol, and another space, And then I'm going to do partial, and we are still differentiating with respect to y, sorry, with respect to r, but this time we're differentiating y, right? So you get this, right? And now you'll notice that there's that little space. If you look at the actual matrix itself, there's that little space that showed up, yeah? And that's because this and symbol basically means that in the first row, we want this and this, okay? Now, that said, the number of and symbols that you have is always one less than the number of C's that you have, yeah? Because otherwise, if I put another and symbol and another thing after the and symbol, that means I'm wanting to put things into 3 columns when there's only 2, because I've used the array environment, right? So that's how that works. Now, if I want to create a new row, another space and //, right? So this double backslash here is a new line character. And in the context of us working with arrays, this just puts you onto the next line, right? So go figure. That one's pretty self-explanatory. So what I'm going to do now is we have the exact same row, except we're differentiating with respect to theta, right? So I'm just going to copy and paste this down here. And I'm going to replace my r's with theta, right? And so now you'll notice, okay, so we get a matrix. We see that our left and right kind of these braces have adjusted their size so that they kind of capture all of the elements in the thing. And just to justify some things, if you drop the curly bracket before the right and the curly bracket right after the left here, the braces would no longer adjust their size automatically. So you get really weird, you just get a really weird looking matrix, right? But if you kind of include these curly brackets, that works like that. And this is kind of the general structure, right? So all of this kind of end array, close bracket, right, left, open bracket, begin array, all of that, that's what I like to call just flow, basically, right? So it doesn't actually kind of contribute to the contents of the matrix, but it contributes to how it looks. Yeah. So if we want the matrix to look nice, this is how I do it. Granted, I'm aware of the fact that there are easier ways of doing this. But the nice thing about knowing how to work with the array environment is that it transfers to some kind of other areas of LaTeX as well, right? So for example, there's another environment called tabular, which lets you do tables. And you can kind of insert kind of horizontal and diagonal vertical lines and stuff in your tables. And that kind of works really nicely. And I think, if I'm not wrong, I can do this. That works. Yes, I can. So what I just did, right, is I replaced the space, right? So this character used, I need to not put the cursor there. Hang on, sorry. Right, so this character, this bar in between the C's, right? This used to be a space. And when it was a space, this matrix didn't have this line, right? And then I added that bar in there. And then it added the line in forward, right? So this is, I mean, this is kind of a useful trick if you're kind of, you know, trying to write down augmented matrices or something along those lines, where you have kind of your normal curly brackets on the outside, but you've got this kind of vertical bar that separates the two matrices that you're kind of packing together. So that's a useful trick. And also, the other thing that you can do as well, I believe this works, is if I get rid of that bar on the inside, and put 2 bars like this on the outside. Yeah, okay. So if I did that, right, and got rid of this left and right, sorry, I know I'm kind of doing a lot, right? But if I did this, right, so I put 2 bars on the outside, then you'll notice, well, these 2 expressions are equal, right? So before we were messing around with kind of left and right and these kind of vertical bars to make sure that it lines up with the fraction. Array just does it for us. Yeah, so we take these vertical bars, put them on the outside of the columns, and then LaTeX knows, oh, okay, you just want to delimit your matrix. Well, okay, LaTeX thinks it's an array, we know it's a matrix. It goes, okay, so you want to tack these horizontal bars onto the left and right of the matrix. Okay, so in the interest of time, we're probably gonna actually, we might have to wrap it up here because we don't really have an awful lot of time to get started on much of the other discussions. But look, that said, already just in the stuff that we've spoken about today, there is a lot of really, really useful content. I mean, if you just focus on kind of the stuff that we've just produced, yeah, I mean, these 2 lines cover most of what you'll want to do in analysis.
And these two lines cover most of what you'll want to do in methods and linear algebra. So, you know, there's that. We've also spoken about partial derivatives. We've also kind of seen, you know, how instead of doing, if you didn't want to do partial derivatives, you were just doing normal derivatives, you could just do your backslash frac and just use kind of normal dx and dy as well. So all in all, at the end of today's session, we have basically covered, we've covered some things related to kind of delimiting expressions, right? So your brackets, left and right, kind of square, round, curly. We haven't looked at triangular brackets, but as is the case with much of the issues that you'll ever encounter in LaTeX, you know, Google is your friend. So if you kind of show up to Google and go, hey Google, how do I do triangular brackets in LaTeX? I guarantee you will be the first result. So we've looked at kind of delimiting expressions. We've looked at just a couple of kind of neat tricks. We've looked at kind of exponentiation, less than or greater than or equal to symbols. We've looked at square roots. And we've looked at some calculus, right? So those are kind of the integral symbols as well as the partial derivative symbols. We've looked at how we can construct matrices, so to speak. And by the way, in case you're wondering, if I wanted to, for example, have a third line after this, yeah, I just put another new line character at the end of this, and then I have my kind of extra line underneath, right? So this method of doing matrices really does cover any size matrix. You can do quite literally anything with it. You know, obviously, if your matrix is 100 by 100, you're not going to want to, but it is possible. But yeah, we've talked a little bit about unlabeled equation environments. We've spoken again about the inline math environment. And yeah, I think probably what we'll do is, we are going to try and, like I said, kind of at the start of the session, we are going to try and run this as a bit of a continuous kind of, basically a course, right? Basically just a course. And so what that means is that probably the next session that we host, yes, the next session that we host after reading week is probably going to just pick up again, kind of at where we stopped today. Yeah, I might kind of go away and revisit the document and add in some more interesting stuff. Yeah, that's all I have. I am going to be here for a little bit longer still, so